Hey, AP Pre-Calc. It's Miss Adams from Flamingo Math. Today we're going to explore implicitly defined functions in Lesson 5 for Unit 4. Let's read carefully about the definition for implicit functions. We know that the set of ordered pairs like x, y is known as a relationship. And when that relation relates a single value of y, for each value of x, we call that relation a function. If we can solve the equation for y in terms of x, then we can say that the function is in explicit form. But in general, when a function is defined by an equation in two variables that are x and y, we say that the function is implicitly defined. For example, x squared minus 2y equals 4 is called an implicitly defined function. If we isolated y, then we would say it is solved for y in terms of x, and that is called explicit form. Let's look at example 1. We have xy plus 3y equals 6. In this case, it's possible to factor out y as a common factor in the first two terms. And then when we solve for y in terms of x, we have a rational function, 6 divided by the quantity x plus 3. This is a function as long as we don't allow x to be -3. It'll stay a function. -3 is a vertical asymptote for that function. In this case, x squared minus y squared equals 9. If we isolate the y squared to one side, we have x squared minus 9. And then taking the square root of both sides, we have two different equations, either x squared minus 9, or we have negative, or the opposite of x squared minus 9. That happens using the rule whenever you are the author of taking the square root of the left side to get rid of the square, you must take the positive and negative square root of the right side. That's what happened here. So we either have positive radical x squared minus 9 or the opposite of radical x squared minus 9. That causes this to be just a relation. It's not a function. And the reason that we can show, just for example, we could use an ordered pair. If I let x be 5, then y could either be 4, or if I let x be -5, then y could also be +4. So this creates a hyperbola. X squared minus y squared equals 9. This is a hyperbola. Does not relate as a function. In example 2, we want to look at x y minus 2y is equal to 4, and we want to solve the equation in terms of x. So it's similar to example 1a. We're factoring out a y in both terms, so that leaves the factor x minus 2, and then y is the rational function 4 divided by the quantity x minus 2. X can't be 2. That's a vertical asymptote on our graph. We can sketch that in because this is undefined. And finding the solutions, we could substitute our -4 and -3 and -2 and so on to find all of the values for the function. And then we can graph that when x is -2, y is -1. When x is 0, y is -2. X is 1, y is -4. Wait, when x is 1, y is -4. Yes, so we have this situation going. We also know, let's add this, that y equals 0 is the horizontal asymptote, and x equals 2 is the vertical asymptote. 0, -2 is the y-intercept. There is no x-intercept because y equals 0 is a vertical break in the range. And then on the other side of the vertical asymptote, when x is 3, y is 4. When x is 4, y is 2. And that graph is coming along like this branch here. So we've graphed that rational function defined explicitly up here and given to us in implicit form. In example 3, can the equation x squared plus y squared equals 16 represent a function with an input value of x and an output value of y, where y equals f of x? Well, we should know from algebra and geometry that the answer to that question is no, because this equation is the equation for the graph of a circle. And x squared plus y squared equals 16 is going to look like y squared equals 16 minus x squared. And when you introduce the square root of both sides, we get y on the left and either the positive or negative square root of 16 minus x squared. Our center of our circle is located at the origin. The radius is the square root of 16, and we have a circle centered at the origin with radius 4. And I'll do my best to draw that looking like a circle. So it is an implicitly defined function, a circle centered at the origin, radius 4. Moving on to example 4, given x cubed minus y squared equals 8, we want to solve the equation for y in terms of x. Isolating y squared is equal to x cubed minus 8. So y is the positive or negative square root of x cubed minus 8. If we make a table real quickly, we could say x and y, just to get a feel for what's going on, 2, 0. If we let x be 3, we got plus or minus square root of 19. If x is 4, plus or minus square root of 28. So looking at that on a calculator, we've got 2, 0, and 4 is the square root of 28, so that's going to be somewhere close to 7. And 3 is the square root of 19, so a little bit bigger than 4. And it's going to be a branch that goes off this way in both directions. So we know x cubed minus 8 has to be greater than 0. X cubed has to be greater than 8. So x has to be greater than or equal to 2, because we can't have a negative under the radical. And then finally, for example 5, let's describe the graph of the relation x squared minus 2xy plus y squared is 25. We have a hint here. Either you can factor and find solutions. Can you factor and find solutions? Well, let's see. Can we factor? It looks like this left side is a perfect square. So x squared minus 2xy plus y squared is a perfect square trinomial. that can be factored as the quantity x minus y squared. And if that's equal to 25, and we take the square root of the left side to clear the square there, we get x minus y. But we also have to take the positive or negative square root of 25, which gives us plus or minus 5. Then if we isolate the y, we know that y is going to be equal to either x plus 5 or y is going to be equal to x minus 5. So we end up having two different lines. They're parallel to each other. The slope is 1. One has a y-intercept at 0, 5, and one has a y-intercept of 0, negative 5. So if we can draw those here, you can see what happens. 0, 5 and 0, negative 5. We have a set of parallel lines. Slope is 1. Y-intercept is at 0, 5 on one of them, and the y-intercept as 0, negative 5 on the other. That's clearly a relation and not a function. Join me tomorrow for the second half of Lesson 5 in AP Pre-Calc.